How do you load share with spanning tree protocol? You manipulate who the root bridge is for every single spanning tree instance. So in this example, switch 1 is the root bridge for VLAN 10. We have switch 2, who is the root bridge for VLAN 20. So the spanning tree topology that is built for VLAN 10 would probably look like this, providing optimal traffic flow. And then for VLAN 20, it would look like this, providing optimal traffic flow as well. In addition to that, we are providing load sharing. We are utilizing all the potential links in the topology that can optimize our traffic flow. However, if we are implementing HSRP for our gateway redundancy, we want to make sure we map our active forwarder to the HSRP route. So in this example, we want switch 1 to be the active forwarder for group 10, right over here. The active forwarder for group 10. Why is that? Because it is the root bridge for VLAN 10. Likewise, switch 2 should be the active forwarder for group 20 because it's the root bridge for VLAN 20. Therefore, everybody in VLAN 10 will be configured with the virtual IP address for group 10, and everybody in VLAN 20 will be configured with the virtual IP address for group 20. But notice the mapping. Active with the root bridge in both cases. And what have we just done? We've provided load sharing for HSRP as well. Because now the VLAN 10 traffic is going to use switch 1 as its default gateway. If a failover happens, they go to switch 2. VLAN 20 traffic by default is now going to use switch 2 as their default gateway because it's the active forwarder. So not only are we load sharing with spanning tree protocol on the links, we are now load sharing the default gateway job because it's not a single device now that has to be the default gateway for everybody. We could have switch 1 as the default gateway for the VLAN 10 users and switch 2 as the default gateway for the VLAN 20 users. And then if there's a failure, we could have the other device or the remaining device be the default gateway for all users and vice versa. So these two multi-layer switches can back each other up. How do we accomplish this? We accomplish it by creating multiple groups. This is known as multiple HSRP. So in this example, switch 1 is configured with 2 HSRP groups. We have HSRP group 10 here. The configuration is underneath interface VLAN 10. And we have group 20 configured under interface VLAN 20. So the group 10 under interface VLAN 10 has the IP address of 10.1.10.1, which is the virtual IP address that will be configured on all the end stations in that subnet. It has a priority of 110, and preemption is enabled. If we look at interface VLAN 20 and group 20, the virtual IP address is 10.1.20.1, so everybody in VLAN 20 will be configured with this address as the default gateway. But notice the priority is 90, and preemption is enabled. Why is the priority set to 90? Well, if we examine switch 2's configuration, we'll see that the configuration is reversed for the groups. Notice how standby 10 has a priority of 90 now, and standby 20 has a priority of 110. Why are we doing this? Well, by giving group 20 a higher priority on switch 2 and enabling preemption, it will force switch 2 to be the active forwarder, so we've accomplished our goal. By giving the priority for group 10 on switch 2 90, it ensures that switch 1, having this higher priority of 110, becomes the active forwarder for group 10. Don't forget, preemption has to be enabled to ensure that that device will be the active forwarder. So we've accomplished our goal here. But we also have to make sure that the root bridges match for the VLANs. So in this case, we want switch 1 to be the root bridge for VLAN 10. The command used here was spanning tree VLAN 10 root primary. making switch 1 the primary root bridge, but you could have set the priority manually with spanning tree VLAN 10 priority 0 as an example. But you also want to make sure switch 1 can become the secondary root bridge for VLAN 20, meaning it has the next highest or next lowest, bridge ID. That way there, if switch 2 fails, which is going to be the primary root bridge for VLAN 20, switch 1 takes over. We don't want the access layer switch to take over at all. So if we examine now switch 2, we'll see that the spanning tree VLAN 20 command has root primary associated with it, making it the primary root bridge. Whereas on switch 1, we saw spanning tree VLAN 20 root secondary. So the goal here is to give switch 1 the lower priority for VLAN 10, and then the next lowest priority for VLAN 20, so it will take over the root bridge job if switch 2 goes away for VLAN 20. When we look at switch 2, the goal is to make sure that VLAN 20 has the lowest priority, so that way there switch 2 becomes that root bridge for VLAN 20, and we give VLAN 10 the next best priority when compared to switch 1. That way there, if switch 1 goes away, switch 2 becomes the root bridge. So we never, ever, ever have to worry about this switch at the access layer ever becoming the root bridge. So this is load sharing. We are load sharing the job of the default gateway amongst multiple devices, but it's still on a subnet by subnet basis. So if you notice, switch 1 is primarily going to be forwarding traffic for the 10.1.10.0 subnet, and switch 2 is going to be forwarding traffic for the 10.1.20 subnet, which are mapped to VLAN 10 and VLAN 20. Now, if a failure happens, then they have the ability to help each other out, meaning take over the active role for both of them and take over the root bridge role for both of them.